Hello students. So today I am doing class 12 science. The topic is matrix. So in the last class also we were doing the same topic, matrix. So this is your continuation class. Okay. So same exercise 1, page number 134, and here each question carries 4 marks now. So question number 1 of 1. Solve for x and y. If 2, now this is the matrix sign, square bracket is the matrix sign. This is the second order matrix. It is x 5 7 y minus 3 plus this is also the second order matrix, that is 3 4 1 2 is equal to on the right hand side also second order matrix is given, that is 7 14 15 and 14. So let us solve this equation to get the values of x and y. Okay, so this is the given part. Okay, now 2 is the scalar multiplication of this matrix, so you can multiply all the elements of the matrix by 2 in this case. So it is 2x and 2 5s are 10, 2 7s are 14, and multiply by 2 here, it is 2y minus 6 plus this is the second matrix, remains same, 3 4 1 2, which is equal to on the right hand side it is 7 14 15 and this is 14. Right, so now on the left hand side you can add these two matrices because they are of same order, right? So you can add these two matrices, 2x plus 3, it is 2x plus 3, then 10 plus 4 is 14, the next 14 plus 1 is 0 15, and now 2y minus 6 plus 2, that is 2y, and minus 6 plus 2 is minus 4. So matrix sign is closed is equal to now it is 7 14 and this is 15 14. So is that clear now? So now these are the equality of two matrices. When are the two matrices said to be equal? If they have the same order. The two matrices are said to be equal if they have the same order and their corresponding elements are also equal. So in the first row, first element should be equal to this first element, second element is equal to second element. In the second row also, on both the sides, first element is equal to first element and second element is equal to second element, right? So here 14 is equal to 14, 15 is equal to 15, that is right. Now we can equate 2x plus 3 with 7. These two numbers must be equal. Therefore 2x plus 3 is equal to 7, right? Or 2x is equal to 7 minus 3 is 4. That means x is equal to 4 by 2 is 2. So we have got the value for x. So again these two numbers must be equal. These two numbers must be equal because this is from the property of equality of two matrices. So now we can equate 2y minus 4 with 14. 2y minus 4 is equal to 14. Okay. So or now it is 2y is equal to minus 4 because plus on the right hand side, 14 plus 4 18, or this is y is equal to 18 by 2 is your 9. So we got the answer. So what are the values of x and y? That is x is equal to 2 and y is equal to 9. So this is the answer. So x is equal to 2 and y is equal to 9. Is that clear now? So now we'll do the next question. We will do the next number now. That is 4 number 1. Here you have to solve for a, b, c and d. So a, b, c and d are the unknown quantities here when these two matrices are equal. So you know from the equality of two matrices that the corresponding elements are equal. Both the matrices have the same order and their corresponding elements should also be equal. So in the first row, first element is equal to first element from both the sides. So you can equate it. So b plus c is equal to what? it is 9 minus D. So in the first row, the first element on both the sides are equated. Okay. So or B plus C plus D is equal to 9. Suppose this is equation 1. Again in the first row, second elements are equal. So second elements from both the sides are equated now. So what do we get? Therefore, C plus A is equal to 8 minus D. Right? So or we can write here A plus C plus D is equal to 8. So this is equation 2. Again in the second row also, you can equate the first elements on both the sides. That means therefore A plus B is equal to 7 minus D, or A plus B plus D is equal to 7. So this is equation number 3, right? So next one is you can equate the second elements from the second row on both the sides. So that means you can equate again A plus B is equal to, again A plus B is equal to what? 6 minus C, or A plus B plus C is equal to 6. That is equation number 4. So I think you have understood it. So now you have to solve these 4 equations to get the values of A, B, C and D. So how can you solve it? So let us add all this equation, that is adding 1, 2, 3 and 4. So let us add them. So adding 1, 2, 3 and 4. So let us add them. So if you add all these 4, this left hand side should be added, that is this plus this plus this plus this, right? So now A plus, this is A plus A plus A, 3A. This is 3A plus, how many B's are there? B plus B plus B plus 3B, plus again you can add those C plus this C plus 3C, plus again this D plus D plus D, that is 3D. 3D is equal to, you can add those right hand side, 9 plus 8, 17. 17 plus 7 is 24, and 24 plus 6 is 30. Right? So it is 30. Is that clear? So what is common out here? It is 3. So within bracket A plus B plus C plus D is equal to what? It is 30. Right? So let us get the value for A plus B plus C plus D. Now we can take this 3 to the right hand side, or A plus B plus C plus D is equal to 30 divided by 3. Okay? So you can cancel here, 3 ones are 3, 3 tens are 30. So, or it is A plus B plus C plus D is equal to, this one is 10. So suppose this is equation number 5. So I think I have understood it. So now, what will you do now in the next step? Since you have to get the values of A, B, C and D, that is individual values of A, B, C and D, you have to find it. Okay? So what we will do here is 5 minus 1. If you do 5 minus 1, if you subtract 1 from 5, this B, C, D will be cancelled and you will get the value for A. So let us write from 5 and 1. So let us write here 5, A plus B plus C plus D is equal to 10, right? And let us write number 1. That is B plus C plus D is equal to what? It is 9. So now subtract it. We can subtract it, minus, 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 minus. So your BB gets cancels, CC cancels, DD gets cancels. So what do we get? That is A is equal to 1. So we have got the value for A. So I think I've understood it. We have got the value for A. Now again you can get the value for B by subtracting 2 from 5. Subtract 2 from 5, right? So from 5 and 2. So let us write equation number 5 first. A plus B plus C plus D is equal to what? It is 10. And let us write number 2. A plus C plus D is equal to 8. So let us subtract it. Minus, 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 minus. So here dt gets cancelled, cc gets cancelled, a gets cancelled. So we get b is equal to 10 minus 8 is 2. Now again subtract 3 from 5. We can get the value of c, right? So again from 5 and 3. From 5 and 3. Okay. So let us write number 5 first. A plus B plus C plus D is equal to what? It is 10. And let us subtract 3 from 5. What is number 3? A plus B plus D is equal to 7. So subtract them. Sign changes here. So here A gets cancelled, BB gets cancelled, DD gets cancelled. So C is equal to 10 minus 7 is 3. Got it? So we have got the value of C here. Now we can get the value for D by subtracting 4 from 5. Right? And so now from 5 and 4. From 5 and 4. And so now what is number 5? A plus B plus C plus D is equal to 10. And let us write down this number 4. So we are writing this number 4. What is number 4 here? A plus B plus C is equal to 6 only. Number 5 is written from here. A plus B plus C plus D is equal to 10. And what is number 4? It is A plus B plus C is equal to 6. So now let us subtract them. Minus, 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 minus. A gets cancelled, BB gets cancelled, CC gets cancelled. So D is equal to what is 10 minus 6? It is 4. Okay. So we got all the values of A, B, C and D. So now let us write down the answers here. So write down the answers. So A is equal to 1, right? B is equal to 2. C is equal to 3. And what is D? D is equal to 4. And D is equal to 4. So these are the answers. Is that clear now? So you can copy it. Now we'll do the next question. Let's do question number 5 of number 1. You have to find out the values of x, y, z and t for which these are the given matrices. So 3 is the scalar multiplication of this matrix 3, and this is the matrix, second order matrix x, y, z, t is equal to, this is the second order matrix again, x6 minus 1 2t plus, and this is also the second order matrix, that is 4 x plus y z plus t, and 3 is given, right? So these are the equations in terms of matrices. You have to get the values of x, y, z and t. So this is the given matrix. Let us solve it. Or now this is 3 is the scalar multiplication of this matrix. So you have to multiply all these elements by 3. So what do we get? It is 3x, 3y, 3z, 3t, which is equal to. Now on the right hand side, you can add these two matrices because they are of same order and the corresponding elements should be added. So what do we get? X plus 4, first element are added. Then 6 plus x plus y, that is x plus y plus 6, right? Then next minus 1 plus z plus t, minus 1 plus z plus t. Next 2t plus 3. Next is 2t plus 3. So I think I have understood it. Now from the equality of two matrices, you can write down that their corresponding elements are also equal. That means From the first row, first element is equal to first element, second element is equal to second element, and from the second row also, first element is equal to first element and second element is equal to second element. So let us equate this first element is equal to first element from the first row, okay? Or 3x is equal to x plus 4. So let us solve it, or x is taken to the left hand side. So 3x minus x is equal to 4, or 2x is equal to 4, or what is the value for x? 4 by 2 is equal to 2. So now again you can equate this second element is equal to second element from the first row, right? So again 3y is equal to x plus y plus 6, right? So, or let us take this plus y to the left hand side, becomes minus y. So 3y minus y is equal to, what is the value for x here? It is 2. It is 2 plus 6, right? Or what is 3y minus y? It is 2y is equal to 8. Or what is the value for y? Y is equal to 2 4s are 8. That is 8 by 2. So we got the value for y, which is equal to 4. Okay. So now next, you can equate this second term is equal to second term from the second row, so that we can get the value for t in this case. Now again you can equate 3t is equal to 2t plus 3. 3t is equal to 2t plus 3. Right? So now let us take that 2t to the left hand side. So it is 3t minus 2t is equal to 3. 2t is taken to the left hand side and it becomes minus 2t. What is 3t minus 2t? That is t is equal to 3. So we got the value for t. That is t is equal to 3. Now we can equate this first element is equal to first element from the second row on both the sides, right? Again we can write 3z is equal to this 3z is equal to this element, that is minus 1 plus z plus t. Minus 1 plus z plus t. Or now here you can put the value for t. So let us take this plus z to the left hand side, becomes minus z. So 3z minus z is equal to minus 1. And what is plus t out here? Plus t is plus 3. You can put the value of t there. Okay. So what is 3z minus z? It is 2z is equal to, what is 3 minus 1? It is 2. Or what is z is equal to 2 by 2? That is 1. So we have got all the values of x, y, z and t. So let us write down the answers now. So what are the answers here? Therefore, x is equal to 2, y is equal to 4, z is equal to 1 and t is equal to 3. So these are the answers. So I think you have understood it. You can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 2 from the same exercise 1, and each question carries 4 marks, right? So question number 2 is test whether the following matrices A and B are conformable for A plus B, AB and AB, and find the values when they are conformable. So in this case, the two matrices A and B are given. So you have to test whether you can find A plus B or not, whether you can find AB and BA. You have to check it. Okay. So number 1 is your homework. Let's do question number 2. You can do number 1 easily. Let's do question number 2. So the matrices, the two matrices A and B are given out here. So in this case, whether A plus B is conformable or not. That means, can you find out A plus B or not? We are doing number 2. We are doing this question number 2, right? So can you find out A plus B? So in order to find A plus B, that is, A plus B will be possible if they have the same order. But in this case, A is of order 3 cross 2. What is the order of the matrix A? It is 3 rows and 2 columns. So A is 3 cross 2 matrix. A is of order 3 cross 2. And B is of order 3 rows and 3 columns. That is, the order of the matrix B is 3 cross 3. That means they are of not same order. They are not of the same order, so you cannot find out A plus B. So here A plus B is not conformable. Is not conformable because A and B are not of the same order. A plus B is not conformable because A and B are not of the same order. That means you cannot find out A plus B. Okay? So now, can you find out matrix multiplication AB here? In order to get the matrix multiplication AB, since A is written first out here, you have to check the number of columns for the matrix A, and B is written afterwards, you have to check the number of rows of B. So whether matrix multiplication AB is possible or not, the number of columns of A should be equal to the number of columns of number of rows of B. For AB to be conformable, for the matrix multiplication AB to be conformable, number of columns of A should be equal to the number of rows of B. So what are the number of columns of A here? It is 2. And what are the number of rows of B? It is 3. Are they equal? No. Number of columns of A is 2, number of rows of B is 3. So they are not equal. So the matrix multiplication AB is not conformable. Is that clear? So here the matrix multiplication AB is not conformable. What is the reason? Because you cannot multiply them, because number of columns of A is not equal to number of rows of B. Is that clear? So we cannot find out AB, right? So now can you find out AB, whether the matrix multiplication BA is conformable? Can you find out BA? Now here B is written first. You have to check the number of columns of the matrix B. What are the number of columns of the matrix B? It is 3. Okay? And for this A, you should check the number of rows for the matrix A. How many rows are there for matrix A? It is 3 rows. That means number of columns of B is equal to number of rows of A. That means you can find out the matrix multiplication BA. Okay? So for this number 2, the matrix multiplication so I'll write here, the matrix multiplication BA is possible, or you may write is conformable, because what is the number of columns of B? It is 3. What is the number of rows of A? It is 3. That means they are equal, because the number of columns of B is equal to number of rows of A. which is equal to what? It is 3. Okay, so in this case you have to find out the matrix multiplication BA because it is conformable. Okay, so therefore BA is equal to, so what is B now here? B is the third order matrix, that is it is 3 8 5 2 1 1 and 1 3 3, right, into A. What is A here? Here is 2 3 5 6 and it is 7 8. Okay, so you can multiply them because number of columns of B is equal to number of rows of A. So what will be the order of BA? Can you tell me what is the order of BA? In this case, this B, matrix B is of order 3 cross 3 and matrix A is of order 3 rows 2 columns, 3 cross 2. That means here number of columns is equal to number of rows here. So the matrix BA is of order 3 cross 2. That means the matrix BA is of order 3 cross 2. This 3 3 are equal, that means they are cancelled. So matrix BA is of order 3 cross 2. Is that clear? So now let us multiply them. Therefore BA is equal to, how will you multiply it? You know how to multiply it. Row by column. You know row by column, isn't it? This first row is multiplied by first column and corresponding elements are multiplied. First element into first element, second element into second element, plus third element into third element. That is 3 2s are 6 plus 8 5s are 40 plus 5 7s are, it is 35. Right? So this is the first element of the first row. Now again, there is second column also you have to multiply. Multiply first row by second column. 3 3s are 9 plus 8 6s are 48 plus 8 5s are 40. So this is the first row of BA. Now next, again you have to multiply second row by first column. That is 2 2s are 4 plus 1 5s are 5 plus 1 7s are 7. Right? Next, now this second row should multiply this second column. The corresponding elements should be multiplied. 2 3s are 6 plus 1 6 are 6 plus 1 8s are 8. Right? So this is your second row of BA. Next, now third row should be multiplied by the first column. Corresponding elements should be multiplied. That is 1 2s are 2 plus 3 5s are 15 plus 3 7s are 21. Right? And next, what is the second element of the third row? Again, this third row should be multiplied by the second column. Corresponding elements should be multiplied. That means first element into first element, second element into second element, plus third element into third element. Okay? Now 1 3s are 3 plus 3 6s are 18 plus 3 8s are 24. Right? So this is the matrix BA. Now let's simplify it. Therefore BA is equal to, what is it? So you can add them. 6 plus 5 is 11 1. This is 4 plus 4 is 8, that is 81. So you can add them. 9 plus 8 17 7 1. 5 plus 4 is 9. Next, 5 plus 4 9, 9 plus 7 16, 6 plus 6 12 plus 8 20. Next, 2 plus 5 7 plus 1 8, that means it is 38. And 8 plus 3 11 plus 4 8 plus 3 11 plus 4 15. 5 1 3 plus 1 is 4. So is that clear? So this is BA. So this is the matrix BA. So I think you have understood it. So let's do the next problem. Now we'll do the next question, that is question number 3. When are the two matrices A and B said to be conformable for the product AB? So the matrix multiplication AB, when is it possible? You have to write it. When the two matrices A and B said to be conformable for the product AB. So when is this product AB possible? You know that for the first matrix A, you have to see the number of columns. You have to consider the number of columns for the matrix A, and for the next matrix B, you have to consider the number of rows. So if they are equal, then the matrix multiplication AB is conformable. You can find out the matrix multiplication AB. So when are the two matrices A and B said to be conformable for the product AB? That is, for the first matrix A, number of columns of A, and for the next matrix B, number of rows of B. They should be equal. Okay. So now let us write down the answer for the first part. The two matrices A and B are said to be conformable for the product AB The two matrices A and B are said to be conformable for the product AB when the number of columns of matrix A is equal to what? The number of rows of matrix B. The number of rows of matrix B. So the matrix multiplication AB is possible when the number of columns of the matrix A is equal to the number of rows of matrix B. So that is the answer for the first part. Is it clear now? So you can copy it as a next. If A is equal to this matrix and B is equal to that matrix, you have to show that AB is equal to BA. Okay? And also, you have to prove that is it in general true for matrix multiplication? So in general, is that true? That is AB is equal to BA is true for matrix multiplication in general. You have to check it. You have to give an example to justify your answer. Actually in general, AB not equal to BA. So you have to give an example to prove that in general AB is not equal to BA. Okay. So let us find out AB first. So therefore AB is equal to, what is A out here? It is 1, 2, 3, 1, 3, 3, 1, 2, 4. Right? This is the matrix A. And let us write down the matrix B. What is matrix B here? It is 6, minus 2, minus 3, minus 1, 1, 0, and minus 1, 0, 1. Right? So let us do this matrix multiplication. That is row by column. So therefore AB is equal to, what is here? This first row should multiply this first column. First row is multiplied by first column now. The corresponding elements should be multiplied. You know that 1 6 are 6, 2 into minus 1, minus 2, 3 into minus 1, minus 3. This is the first element of the first row. Again, first row should be multiplied by this second column. Corresponding elements should be multiplied. 1 into minus 2, plus 2 ones are 2, plus 3 zeros are 0. That is the second element of the first row. Next, this first row should be multiplied by this second column. corresponding elements should be multiplied. 1 into minus 3 plus 2 zeros are 0 plus 3 ones are 3. Right? So next, this second row should be multiplied by the first column now. You will write it in the first row of the first element of the second row. You will write it in the first element of the second row. That is 1 6 are 6. That is row by column. 1 6 are 6. 3 into minus 1 minus 3. 3 into minus 1 minus 3. Right? Again, this second row should be multiplied by the second column. 1 into minus 2 plus 3 ones are 3 plus 0. Right? Again, this second row should be multiplied by the third column. 1 into minus 3 is minus 3 plus 0 into 3 is 0 plus it is 3 ones are 3. So this is the second row. Next, third row should be multiplied by this first column. 1 6 are 6. This is 2 into minus 1 minus 2. 4 into minus 1, that is minus 4. Right? So next one is this third row should be multiplied by the second column. 1 into minus 2 plus 2 ones are 2 plus 4 zeros are 0. Next, again, this third row should be multiplied by the third column. 1 into minus 3 plus 0 plus 4. So this is the matrix. Okay. So let's simplify it. So AB is equal to, let us simplify it. 6 minus 2 minus 3. This is minus 5. 6 minus 5 is 1. Right? And this minus 2 plus 2 is 0. Minus 3 plus 3 is also 0. This 6 minus 6, 0. Minus 2 plus 3 plus 0, 1. Minus 3 plus 3, this is 0. Right? And this is also 6 minus 6, 0. Minus 2 plus 2, 0. And last one, 4 minus 3 is 1. So what type of matrix is this one? This is known as identity matrix. You know that in an identity matrix, the leading diagonal will, the elements in the leading diagonal will be 1 and all other elements are 0. So this is known as the leading diagonal. You know that. I told you about leading diagonal in the first online class in matrix. So this is known as leading diagonal. If the elements in the leading diagonal are all 1 and all other elements are 0, then this is known as identity matrix of order 3. This is identity matrix of order 3. So AB is equal to 1 0 0 0 1 0 0 0 1. Is that clear? So this is your AB. Now let us find out BA, and you have to prove that AB is equal to BA. Okay? So let us find out BA now. And you have to prove again BA is also identity matrix 1 0 0 0 1 0 0 0 1, right? So let us find out BA now. Therefore, BA, which is equal to, now let us write B first now. It is 6 minus 2 minus 3, next, minus 1 1 0, next, minus 1 0 1. This is your B. What is A out here? This one, write down. 1 2 3 1 3 3, and the third row is 1 2 4. This is your 1 2 4, right? So let us multiply these two matrices now. Again, row by column. B is 3 columns and A is 3 rows. That means number of columns of B is your number of rows of A. That means you can multiply the two matrices. Okay. So BA is equal to, now let us multiply first row by first column. 6 ones are 6, minus 2 into 1, minus 2, minus 3 into 1, minus 3. That is the first element of the first row. Okay. First row is multiplied by the second column. 6 into 2, 12. This is minus 6, minus 3 into 2, minus 6. Right? Next, this is the second element of the first row. Now what will be the third element of the first row? First row by third column. 6 into 3, 18. Corresponding elements are to be multiplied. Minus 2 into 3, minus 6. And minus 3 into 4, that is minus 12. Right? So that is the third element of the first row. Next, this second row is multiplied by the first column. So corresponding elements should be multiplied. Minus 1 into 1, minus 1 plus 1 plus 0 ones are 0. Right? This is the first element of the second row. Again, second row is multiplied by first and second column. Second row is multiplied by second column. Minus 1 into 2, minus 2 plus 1 3s are 3 plus 0 2s are 0. Next, again this second row must be multiplied by the third column. Minus 1 into 3, minus 3 plus 1 into 3 plus 3, 0 into 4, that is plus 0. That is the third element of the second row. Is it understood? So next, this third row should be multiplied by the first column. Corresponding elements should be multiplied, right? Minus 1 into 1, minus 1 plus 0 into 1, plus 0 plus 1 ones are plus 1, right? Next, second element. What will be the second element of the third row? Again, this third row should be multiplied by the second column. Corresponding elements should be multiplied. Minus 1 into 2 is minus 2 plus 3 zeros are 0 plus 2 ones are 2. So this is the second element of the third row. Now, this third row is multiplied by third column and the corresponding elements should be multiplied. Okay, minus 1 into 3, minus 3 plus 0 into 3 plus 0 plus 1 4s are, this is 4. So we have got this BA. Okay, so therefore BA is equal to, so BA is equal to what? This is 6 minus 2 minus 3, 6 minus 5, 1. This is 12 minus 6 minus 6, minus 6 minus 6 minus 12 plus 12 is 0. And also 18 minus 18, that is also 0. Next, minus 1 plus 1, 0. Minus 2 plus 3, 1. Minus 3 plus 3, 0. Is that clear? Next, minus 1 plus 1, 0. Minus 2 plus 2, 0. And last one, 4 minus 3 is 1. So here also we are getting the identity matrix, because in this case all the elements in the leading diagonal are 1 and all of the elements are 0. So this is the identity matrix of order 3. So in the previous step also we got the same matrix for AB. That means AB is equal to BA. So we can write here, therefore AB is equal to BA. So it is proved. So I think you have understood it. So now there was a question, that is the third part question was there. Is it in general true for for AB is equal to BA? That was the question, no? The question was, is it in general true for the matrix multiplication? Is it in general true for matrix multiplication, that is AB is equal to BA? Is it in general true for matrix multiplication? That is AB is equal to BA. Is it true in general for matrix multiplication? No. In general, this is not true. That is AB is equal to BA is not true. That is AB not equal to BA. So let us write here. In general, the relation AB is equal to BA is not true. Is not true. That is AB not equal to BA. Now you have to give an example to prove it. Okay. So let us give second order example. Second order matrix. 1, 2, this is 3, 4. And suppose B is equal to minus 4, 1, 0, minus 1. Let us write these two matrices. And let us prove in general AB not equal to BA. Let us find out AB first. So AB, what is A here? We are giving example of second order matrix because it will be easier for you to simplify it. Okay. So now A, what is A? 1, 2, 3, 4. And what is B here? Minus 4, 1, 0, minus 1. Right? So let us multiply them. So let us multiply them. Okay? So AB is equal to now first row by first column. Multiplying first row by first column, 1 into minus 4 plus 2 zeros are 0. Now again this first row should be multiplied by the second column, 1 ones are 1, then 2 into minus 1, minus 2, right? Now this second row should be multiplied by the first column, 3 into minus 4, minus 12, plus 4 zeros are 0. Next, again this second row should be multiplied by the second column, that is 3 ones are 3, this is 3 ones are 3, and minus 4. Minus 4, right? So therefore, what is AB now? So AB is equal to, this is minus 4, minus 1, and then this is minus 12 and minus 1. That is AB is equal to minus 4, minus 1, minus 12, minus 1. That is AB. Now let us find out BA now. So again write down BA. BA is equal to, what is B here in this case? It is minus 4, 1, 0, minus 1. Right? Again you have to write it. And then multiply BA. What is A? 1, 2, 3, 4. It is 1, 2, 3, 4. So let us multiply these two matrices now. And you have to prove AB not equal to BA. So BA is equal to, now multiply first row by first column, minus 4 into 1, minus 4, plus 1 into 3, plus 3, right? First row is multiplied by second column now, minus 4 into corresponding elements should be multiplied, minus 4 into 2, minus 8, and this is plus 4, right? Next, this second row should be multiplied by the first column, 0 ones are, these 0 ones are 0, then minus 3, right? Next, this second row is multiplied by the second column, 0 2s are 0, and minus 1 into 4, minus 4. Is that clear now? So therefore BA is equal to, now this is your minus 4 plus 3, minus 1, minus 8 plus 4, minus 4, and this is 0 minus 3 is minus 3, and 0 minus 4 is minus 4. Is it clear to all of you? So in this case, what do we see? That is, this AB not equal to BA, right? This AB not equal to BA. So therefore you can write here AB not equal to BA. So hence in general AB not equal to BA. That is, we have to prove here, is it in general true for matrix multiplication? So in general AB is equal to BA is not true for matrix multiplication. So in general, hence in general AB is equal to BA is not true. Is not true for matrix multiplication. In general, AB is equal to BA is not true for matrix multiplication. Matrix multiplication. So it is proved. Okay. So we'll do the next question now. Now we are doing question number 10. It is given that if A is equal to, this is the second order matrix. The matrix given here is, within first bracket it is written 1, 4, 2, 3. These are the elements of the matrix A. So that A square minus 4A minus 5I is equal to O. This I and O has usual meanings. I is the identity matrix and O is the norm matrix. And what is the order of this identity matrix and norm matrix? It depends upon the matrix A given. If the matrix A is of second order, this identity matrix and norm matrix are also of same order. Okay? So A is a matrix of order 2. This I and O are the matrices of the same order, that is order 2. Okay? That means what is I here? This is the identity matrix of order 2, you know that, because it depends upon the order of the matrix A, and in the question the order of the matrix A is 2 cross 2. So what is I now? So leading diagonal must be 1, 1. All of the terms should be 0. And what is the norm matrix O? It is all the elements are 0 and it is of the same order, that is 2 cross 2 matrix. Okay? So let us prove this LHS is equal to O. That is LHS is equal to O means left hand side, that is A square minus 4A minus 5I is equal to norm matrix. Okay? So let us write down LHS is equal to A square minus 4A minus 5I. Right? So let us put the values now. What is A square? A dot A minus 4A minus 5I. Right? So is equal to, what is A out here? What is A? 1, 4, 2, 3. It is given 1, 4, 2, 3. Again, what is A? Same matrix 1, 4, 2, 3. You have to multiply these two matrices. That is the same matrix A dot A minus 4. What is A here now? It is also 1, 4, 2, 3. Right? And minus 5. What is I? 1, 0, 0, 1. It is 1, 0, 0, 1. Okay? Now let us simplify it now. So let's simplify it, and you should prove that this expression is equal to norm matrix. So is equal to, now multiply them. You know how to do the matrix multiplication. First row by first column, 1 1s are 1 plus 4 2s are 8. Next, first row by second column, 1 4s are 4 plus 4 3s are 12. Right? Again, second row by first column, 2 1s are 2 plus 3 2s are 6. Again, second row by second column, 2 4s are 8 plus 3 3s are 9. Bracket closed. Okay? Then write down plus here. Now you know that this minus 4 is the scalar multiplication of this matrix. That means all the elements of this matrix must be multiplied by minus 4. That means plus. So within bracket, multiply by minus 4. Minus 4 into 1 is minus 4. Minus 4 into 4 is minus 16. Minus 4 into 2 is minus 8. Minus 4 into 3 is minus 12. Right? Then again, minus 5 is the scalar multiplication of this identity matrix. So write down plus here and multiply all the elements of the matrix by minus 5. So what do we get? It is minus 5, 0, 0, minus 5. Is that clear? So now, let us simplify it. And you should prove is equal to norm matrix. So is equal to 8 plus 1, 9, 4 plus 12, 16, 2 plus 6, 8, 8 plus 9, 17. Plus, now we can add these two matrices. They are of same order. The corresponding elements should be added. Minus 4, minus 5. Minus 9, minus 16 plus 0, minus 16. Minus 8 plus 0, minus 8. Minus 12, minus 5, minus 17. Right? So next, which is equal to, what is the minus sign? 0. corresponding elements should be added. Both these matrices have the same order, that is 2 cross 2, so you can easily add them, but the corresponding elements should be added. So 16 minus 16 is 0, 8 minus 8 is also 0, 17 minus 17 is 0, that is which is equal to O, that is null matrix. So it is proved. Understood? So now I'll give you the homework. And so now these are your homework. You can do it at home. So first you revise all the problems that we did today and do all these problems. Okay. So one number 2 is solve for x, y and z if x plus y 2 1 0, this is the second order matrix, is equal to 2x minus z and 2x minus y 0. So you can use here the definition of equality of two matrices. From the definition of equality of two matrices, you can equate the corresponding elements in this case. That is, first is equal to first element, second is equal to second from the first row, and from the second row, first element is equal to first element. Okay. So equating these corresponding elements, you can get the values of x, y and z. So here also the same question, similar type of question is there. You have to find the values of x, y, z and t for which the following two matrices are equal. You can equate these two matrices and equate the corresponding elements and get the values of x, y, z and t. So here also, number 4, if A is equal to this matrix and B is equal to this matrix, you have to find out both AB as well as BA. Find it, you can do it. And number 5 is if A is equal to this third order matrix and B is equal to this third order matrix, you have to find out the matrix AB minus 2B. First you find out AB. First of all, you find out the matrix AB, right? And then you write AB minus 2B, write down the matrix AB, and then minus 2 into, you have to write down the matrix B and then simplify it. So you can easily get AB minus 2B. Is that clear? So you can do it at home. So this much is for today. So in the next class, we'll do the more problems. Okay?